All right. Um, what makes a function rational? All right. A function is rational if it has a variable in the denominator. All right. So anything so basically it's a fraction. All right. But it's a fraction as long as x or whatever the variable is in the denominator. All right. Just if you have x over 5, that is not a rational function. That's the same thing as 1/5 x. We've dealt with that before. All right. But rational functions are functions where variable is in the denominator. All right. So for examples of that, all right, x plus 5 over x minus 3. It's it's a rational function because of this x in the denominator, not because of the x up top, because of the x in the bottom. Right? It doesn't have to be an x up top. For example, number 2 has y equals 2 over x squared minus x minus 5x. There could be more than one variable in the denominator. All right? It doesn't have to be just one. Right? It could just be x. All right, so all of these are examples of rational functions. Now, one thing that we have to be careful about when we've done quadratics and polynomials, there's been no what we call restrictions on the domain. Basically, meaning, remember, domain is our possible x values, and there is not like it was negative infinity to infinity. It was all real numbers before. There was nothing x couldn't be. You could plug in any values for x, and it would give you you'd be fine. All right. When you have a fraction, you cannot have 0 in the denominator. All right. We can have 0 in the denominator. Meaning, now that we have a variable in the denominator, there's going to be some restrictions on the domain. Meaning, it's not just always going to be negative infinity to infinity. Right? So if we're trying to find the domain for these problems, all right? So if I wanted to find the domain, you need to figure out and solve and set this equal to 0. All right, set the denominator equal to 0, which is obviously if I did x minus 3 equals 0, x equals 3. But in this case, it means x cannot equal 3. So it is everything but 3. All right, that is what the domain is. Now, how do I write that in interval notation? Well, it's just negative infinity to 3 union 3 to infinity. And notice I have parentheses by the 3, meaning 3 is not included. All right, so that is how you represent everything except 3. So to find the domain of rational functions, you set the bottom equal to 0 and you exclude them from the domain. All right. Now, in example 2, all right, you're actually going to have 2 numbers that it can equal. All right. So if I were to set this equal to 0, all right, set this equal to 0, and I factor it, what is that, 8 and 7? So that's x minus 8, x plus 7, which means you would get 8 and negative 7. Right? So the domain is x could be any value. It just can't be 8 and it can't be negative 7. So in this case, you're going to actually have 3 sets of intervals, all right, for your domain. So your domain would be always start with negative infinity and then go to your smallest number, which is negative 7. Then it's union that number to the next number, which is 8, union 8 to infinity. All right. So negative infinity to negative 7, union negative 7 to 8, union 8 to infinity. And that is just a fancy way of saying that it just can't be 8 or negative 7. It can be everything else. All right. Because we do not want 0 in the denominator. And we'll eventually talk graphically what that means. It definitely has an application. All right, here, what's the only thing it can't be? It can't be 0. All right, so you just would do negative infinity to 0, union 0 to infinity. All right, so if it's just one number, you go negative infinity to that number, union that number to infinity. Just make sure you don't have brackets. Right? It can't be brackets. Now, just because you have a rational function like example 4, all right, we have x plus 5 over, that's supposed to be x squared plus 9, in case you can't tell what it says. If I set that equal to 0, all right, well, that's x squared equals -9. Oops, it's -9. So when I take the square root, I get the square root of -9, which is plus or minus what? 3i? That's an imaginary. We're only talking about the real numbers here. We're not talking about imaginaries. So in this case, there is nothing that makes the bottom equal to 0, because no matter what I plug in here, I swear it's going to be a positive number plus a positive number. There's no way I'm going to get 0. So just because there is a rational function doesn't mean the domain can't be everything. You just have to be aware that there might be possible restrictions. So in this case, there is nothing that makes the bottom equal to 0, even though it is a rational function. So the domain is negative infinity to infinity. All right, does anybody have any questions up to this point?
So does that mean if it's imaginary, then the domain is everything?
It means that if there is an imaginary 0, that you don't include that in the domain. That means if that's the only thing that makes it equal to 0, then yes, it is negative infinity to infinity. Okay. Now, this is another common mistake, is we set the top equal to 0 and say it can't be equal to -5. The top can be 0. You can do 0 divided by something. It's fine. It's when 0 is under the line, it's undefined. So don't set the top equal to 0 when we're doing the domain. It's just the bottom. All right, now I'll do one more of these, throw you a little curveball here. So obviously, we have a rational function here where we got x minus 5. So x cannot equal 5. All right, x cannot equal 5. But we got something interesting up here, and we have a square root. All right. And this goes right along, we're talking with imaginaries. The restrictions on a radical is that you can't have a negative inside of the under the radical, right? You cannot have a negative number. If I have a negative number there, that means that it's going to be imaginary. I don't want an imaginary number. So we actually have to deal with two things here. All right. So if I think about this, if I have a number line, I know from 5, I cannot be equal to 5, right? It can be equal to everything else. However, if I were to set the top equal to 0, and the only reason I'm setting the top equal to 0 is because of a radical, I cannot have a negative number. So if I did x plus 1 is equal to 0, x is equal, because it has to be greater than 0, right? X plus 1 has to be greater than 0, which means x has to be greater than -1. -1 is okay, because if I put a -1 in there, I get a square root of 0. Square root of 0 is 0. But anything less than -1, -2, -3. So x has to be greater than -1. So it has to be bigger here, because if it's -2, -2 plus 1 is -1. The square root of -1 is I. That's not good. All right. So we have an extra little element that this doesn't happen often, but just wanted to show you in case you ever see this, that this means that I have to be bigger than -1. This tells me it can't be 5. So based off of this little number line, I have to make do an interval. So I know it has to be bigger than -1. Now, can it be -1? Is it allowed to be -1? Yes, which means I put a bracket. It's a big bracket. -1. I can't go to infinity because it can't be what? It can't be 5. So it's -1 to 5, parentheses, union 5 to infinity. All right. So if this was anything besides the square root, it would be -infinity to 5, union 5 to infinity. But because of this radical, it has to be greater than -1. All right. Like I said, this is a special case. You'll see this every once in a while. But there's only a certain amount of, there's basically 3 functions we have to worry about with restrictions on the domain. The big one is the rationals. The other one is radicals. And then the third one, which we'll do at the end of the year, is logs. But we're not going to worry about that right now. All right, so that is it for domain. Okay. All right, now simplifying radical functions, and then we'll get into multiplying and dividing. When you are simplifying, this is the most common mistake that happens. You cannot, when you are separated by, minuses and pluses here, these are separate terms, right? I can't just be like, those x's cancel. This becomes a 2, that becomes a 1, 2 minus 2 is 0. You can't do that, all right? If they were being multiplied, if it was 2x times 8 and x times 4 each other, when they're separated, separate terms like that, you cannot do that, right? So what you need to do when you're simplifying a rational is you need to make sure the top is factored, and you need to make sure the bottom is factored. All right, now there's nothing you can do with the bottom, but you can simplify the top by taking out a 2. You got 2 times x minus 4 over x minus 4. These you can cancel out because it's 2 times x minus 4, right? So I can cancel out the x minus 4s, and the answer is just 2. Right? So when you have rationals, you got to make sure that the top is factored and the bottom is factored, and then simplify if things cross out. But they have to be like factors, multiplying. It can't be like terms where you're adding it or subtracting it. Right? The most common mistake is canceling things that you cannot cancel. Right? Now, when we multiply fractions. Multiply across the top, you multiply across the bottom. But what we're going to do here is we are going to have to simplify each part first, and then we're going to see if we could cancel things out. All right, so take a second here, copy this problem down, all right, and see if just like simplify each top and bottom. So do x squared minus 9, see what you can do with that. X squared minus 4x plus 4, see what you can do with 2x minus 4, and see what you can do with x squared minus x plus 6. Right, just simplify each top and bottom first. That's it. That's what I want you to do. And then we'll reduce from there. So, excuse me. When you factor each thing, when you simplify, so if you do x squared minus 9, that's a difference of 2 squareds. It's x minus 3 times x plus 3. All right. X squared minus 4x plus 4 is x minus 2 times x minus 2. 2x minus 4, the only thing I can do with that is take out a 2, which leaves me 2 times x minus 2. And x squared minus x plus 6 is x minus 3 and x plus 2. All right. So now, once we do each of those, now we see if there's anything we can cancel out. Now, when you cancel, as long as it's a factor and you're multiplying, which we have here, right? It's all multiplication. There's no pluses or minuses in between them. As long as it's something from the top and something from the bottom, it does not have to be on the top of each other. So for example, I can cancel out this x minus 3 with that x minus 3. Right? If there was a third fraction here, as long as it's on the bottom, as long as you're multiplying a bunch of fractions together, you could cancel out something on the top of one and the bottom of the other, as long as they're factors, all right, not terms. This x minus 2, I can cancel with that x minus 2. All right. Now, there's nothing else that cancels. So when we multiply fractions, we multiply across the top. Now, I don't want to actually multiply 2 times x plus 3 and like distribute the 2. Because remember, I want my final answer to be simplified, meaning the top is factored, the bottom is factored. So you just simply have to write 2 parentheses x plus 3 over x minus 2 times x plus 2. And that is your final answer. Your final answer should be in factored form, right? It's simplified as much as possible. The top needs to be factored. The bottom needs to make sure it's factored all the way through. And then if you cancel everything, great. If you can't, you leave it like that. Just don't make the mistake. Because if I multiply this, guess what you would have to do? You have to take out the GCF all over again. All right, questions on that? Okay. All right, see if you guys can try this one. 2x squared plus 7x minus 15 all over 4x squared minus 100 times 2x squared minus 9x minus 5 all over 4x squared minus 1. All right. So it's almost like you're doing like to start off 4 separate easy little factoring problems, right? Do this one, do the top, bottom of each of them. Then once you do that, that's the hard part. Then it's just it's gratifying just to then cross some stuff out. So I'll give you a minute or two to try that one. Okay. All right. So when we factor all of these, the top of the first fraction there, 2x squared plus 7x minus 15, that's 2x minus 3 times x plus 5. If you see a mistake, just let me know. With this, make sure you take out the 4 first. All right, take out the 4 first. So you would get 4 times 4, and then you get x squared minus 25. But x squared minus 25 is a difference of 2 squares, which is 4 times x minus 5 times x plus 5. All right. Then we have the top here is 2x plus 1 times x minus 5. And then this is another difference of 2 squares, 2x minus 1 times 2x plus 1. Like I said, now that is the difficult part. Now you just get to have fun and see if anything cancels. X plus 5, x plus 5, x minus 5 on top here, x minus 5 on the bottom over there, 2x plus 1, 2x plus 1. Right? So now anything that's left on the top, you rewrite anything that's left on the bottom. So the only thing left on the top is a 2x minus 3. I don't need to put that in parentheses. Don't know why I did. If you do, it's not a big deal. And then the only thing left on the bottom is 4 times 2x minus 1. So 2x minus 3 over 4 times 2x minus 1 is the answer. All right, any questions on that one? Now, the last one we're going to do today is a division one. Now, before we do that, when I multiply fractions, right, we go across the top. 1 times 5 is 5. 2 times 7 is 14. But what if it's 1/2 divided by 5/7, right? When you divide fractions, you're multiplying by its reciprocal. If you guys remember, like keep, change, rearrange, that was like a thing. So basically you rewrite, if I'm doing this problem, I would rewrite it as 1/2 times 7/5. Right? So dividing is the same thing as multiplying. You just have to flip the second fraction. That's it. So when we're looking at this problem right here, right, I'm just going to rewrite. Now, obviously, when you're doing this, you don't have to rewrite it. You can do it. Yeah, but I just want to show you. So you keep the first, everything is exactly the same in the first one. You change the division, to multiplication, and then I flip the second one. So this a squared minus 10a plus 24 goes on the bottom, all right? And the 4a cubed minus 9a goes on top. All right, so now it's just like what we've been doing. So dividing is just multiplying by the reciprocal, right? Dividing by 2 is the same thing as multiplying by 1/2. All right, so that's what we're doing. So when you see division, you're just multiplying by the reciprocal. All right, see if you can go ahead and do factor each and then see if anything cancels out. Yeah, right. Milk. so a squared minus 7a plus 6. Two numbers multiply, give me 6. Add to give me 7. That's 6 and 1. Plus means that same signs are the same. Negative means they're both negative. So x minus 1. Sorry, a minus 1. A minus 6. Oops, I don't know why that's so weird. All right, this one, the only thing I can do is take out a squared, leaving me with 2a minus 3. All right, 4a cubed minus 9a. The first thing I can do is what I did up here. I can take out an a, and it leaves me with 4a squared minus 9, which is a difference of two squares, which is 2a minus 3 and 2a plus 3. A squared minus 10a plus 24. Two numbers multiply give me 24. Add to give me 10. That is a minus 4 and a minus 6. All right. So then cancel. Let's see. 2a minus 3. A minus 6. All right. Now look at this. We have a squared and we have an a, meaning this a is now gone. And this squared is gone, and you leave just with an a. Remember, you can do that, right? Like x over x squared, with the x we cancel on top, just leave with an x on the bottom. So also have to look for the factors that the GCFs that you pull out. I think that's it, right? Yeah. So I am left with a minus 1 times 2a plus 3. Remember, we don't actually FOIL that out. We just write the parentheses. There's an a left on the bottom, and there is an a minus 4. And there you go. All right. So division is just like multiplication. You just have to flip it first, right? Change the division sign to multiplication and flip the second fraction. Other than that, it's exactly what you're doing. You simplify everything, and then you cross things out. All right, it's the easiest, most efficient way of doing things. Any questions on anything we talked about so far?